Good day, viewers. You are welcome back to Tindanious Math and Science Tutorials. If this is your first time, kindly share, like, comment and subscribe for more interesting videos and updates. We've covered extensively on piecewise functions. Today we are going to consider the range and domain of piecewise functions. If this is your first time, kindly visit my previous lecture videos on the introduction to piecewise functions, where we've learned about how to graph piecewise functions. In other words, the geometric definition for piecewise function, how to evaluate piecewise functions, and how to write down the appropriate equations or the formulas for piecewise functions, the characteristics and what have you. Everything about piecewise function is well explained. I want to end on piecewise functions by considering the domain and the range of piecewise functions. Okay, we already know what domain is, right? And range. So domain simply means the set of inputs of a function is just what the domain of the function, and the possible outcome or the possible values of a function is what we call the range of the function. Okay, so in summary, range of a function refers to the possible outcome or the possible values of the function given its domain. All right, good. So in other words, the output, okay, is what we call response in system dynamics or dynamic systems and control systems. Okay, all right. Now you are given this question: find the domain and range of the function f of x. So f of x is given by 5, okay, for this restrictions, okay, or for this set of giving what domain. Good. And this is another function, okay, which is defined over this interval. So we are given a function which is piecewise. So this function and this function, we call them sub functions, okay. All right, good. Now, what is the whole concept of domain with regards to piecewise function? First of all, you pick each function separately, okay? Then you write down its domain. Afterwards, you merge the domain of this function with that of this function, okay? So that is simply the domain of the overall function. So the domain of the piecewise function is simply the union of the subdomain of the given function, which is the subword function. Okay. So now we know how to graph this, right? And we also know how to graph this. Viewers, if this is your first time, visit my previous lecture videos. You can graph this off head and this off head. Okay. But let's go step by step. Considering this, the first one, okay. So we have, let me draw the overall function, okay. So I have it this way. So I have my 0 here. Let's have 1, 2, 3, 4, 5, 6. All right. Let's have -1, -2, -3, -4, -5, -6. Then I have 1, 2, 3, 4, 5, 6, 7, 8. -1, 2, -3, -4, -5, -6, and what have you. So viewers, this is what we are going to do. Let me consider x plus 2, okay? Let's consider x plus 2. So if I have x plus 2 over here, x plus 2, and this is defined when you have 3 less than x less than 8. So because I'm going to plot, I need my x coordinates as well as my y coordinates. So I have my x and my y this way. So this simply means I'll start from somewhere from 4 and I'll end at what? At 7. As simple as that. Okay? So I have 4, I have 5, I have 6, then I have what? I have 7. When x is equal to 4, what will be y? So whenever I see x, it goes to 4. So 4 plus 2, what do we have? We have 6. So I have 6 here. When x is equal to 5, so if I have 5 plus 2, what do I have? 7. When you add 6 here, what do we have? 8. Then I have what? 9. Okay. So now, the coordinates are, I have 4, 6. I have what? 5, 7. I have what? 6, 8. I have what? 7. Then what? Then 9. And what have you? Okay? Good. So let's do the plotting. 4, 6. So this is my 4, and 6 is somewhere here. 6 here. Permit me, it's not drawn to scale, okay? Then I have 5, 7. Okay? So we have 5 here, then 7. Somewhere here. Here. Then we have 6, 8. 6. 8 is somewhere here, somewhere here. Somewhere here. Good. Then I have 7, 9. Right? So 7. Then let's say 9 somewhere here. Good. So I can even include 8, though it's supposed to be less than 8, right? You can even go to 8, okay? Then I'll teach you how to go about it, alright? Let's consider 8. I want us to look out for something. So if here is 8, then we have what? We have 10, okay? So if here is let's say if here is somewhere 3. So in other words, I'm including 8 here and I'll also include 3 here, okay? So here it's supposed to be 5, okay? So I have x and y. So I have 8, 10. This is 8 and 10 will be somewhere here. Somewhere here. Okay? I have 3, 5. This is 3. 5 is somewhere here. So it continues. Is that also good? So viewers, I can draw a straight line. Let me draw a straight line to pass through this point. This way, something like this. Good, right? So viewers, let's look at the interval here. 8, right? Then 3. So this place is, you have 3. From here, I have my 3 here, somewhere here. This is the 3. And 8, right? 8. Is that also good? So viewers, if that's the case, let's see what happens. Now, am I going to shade this endpoint or this endpoint? Let's obey the voice of the inequality. Now I have here 3 less than, right? But here I don't have any fractional, sorry, I don't have any bar. If there's a bar here, it means that place is what? That endpoint is shaded. So because I don't have any bar over here, that means my endpoint is not shaded. As a result of that, this place will be opened at that end. This side, is there a bar there? No, right? So that means I'm going to open the circle at that point. This point 8. This side, good. Do you get it that way? So what happens? I can now discard this point, right? And I can also what? I can also discard what? This point. I'm discarding them because I don't need them. Do you get it that way? That explains why when you have the inequality this way, try and always what? Obey the condition. Okay? So when you start from 2, okay, let's say 1, 2 up to 3. You are not really wrong, okay? Because in the end, you are going to wipe away the unwanted what? Coordinate or the unwanted what? Part of the work, right? So to be on the safer side there, and for time's sake, you don't have to what? You don't have to include this and that because it was not provided by the question. It's not in the question. So I don't also have to what? Include this. Is that also good? So let's try as much as possible to save time. So I don't need this. I don't need anything over here. Good. So -1. That's all, right? Good. So that means it is open at this point, okay? And it is also open at this point. Now, how can we grab this? This is called constant function, okay? Because there's a constant here, right? Good. So what do? I will locate 5, okay? Over there, where is my 5? This is my 5, okay? Constant function. So I will just draw what? A horizontal straight line, right? So have it this way, something like this, like this, like this. Good. Now, let's obey the restrictions or the conditions or the boundaries. I'm starting from 1, right? Where is my 1? This is my 1, right? +1. So let me trace this. From here, then up to 3. So where is 3? This is my 3. Up to this place, right? Good. So that means from here up to here, right? So what it implies is this. This side is not what? It's not needed because what? Because of the condition or the restriction, right? So I don't need this. I don't need them at all. So I only need this point, right? So I also don't need this side. Good. That's all. That is how it goes. So now, do we have a bar here? No. Because I don't have a bar here, what do? I will open that endpoint, okay, using an open circle, okay? There's an open circle at that point, telling us that that place is not what? It's not included. In other words, that place is what? Excluded. And here 3. See, there's a bar here. What does it mean? It means at point 3, that side, okay, that side is included. Do you get that? As a result of that, you apply what we call a solid circle or a closed circle. Okay, so this point is what? Is closed. So this is open at this point, and this is what? This is closed at this point. As simple as that. So how can we write down the range and the domain? Good. So let's write down our coordinates here. So here, let's see. Here, okay. Let's trace. We know that when you draw any graph, okay, on the Cartesian plane, okay, or any function at all, we want to graph them on the graph. The coordinate is denoted by x, then f of x. this way, where x is your x coordinate and f of x here is your what? Is your y coordinate, right? So in other words, let your f of x be equal to what? Y. As simple as that. So let me write down the coordinate at this point. So what do I have? This is the x coordinate, which is what? 1. So I have 1, then comma. Look, this is my y. Starting from where? From 5. So I have it to be a 5. So 1, 5. Now at this point, this is my x. X is what? 3. So I have 3. Then if you trace it here, it's not drawn to scale, but when you trace this to be somewhere, let's say 7, okay, from this side, somewhere 7, okay, so let's say 7, right? Good. Let's consider this side. So here, if you trace from here, what do I have? 8, right? So I have 8, then the y coordinate is somewhere 10, okay? So 10 this way, good. Now let us write down our range and the domain. So the domain of this function is given us, so domain. Now, let's consider this. Viewers, you can decide to use the graph to write down your domain, or from the boundaries of the restrictions given, you can write your domain from there. As simple as that. So let me use this. From 1 up to 3. But remember, the 1 is not inclusive. So from 1 to 3. So from 1 to 3, it means I have 1, okay, up to what? Up to 3. Now, whenever a certain point is not included, okay, in other words, when you don't have a bar over here, we normally use this notation, okay, this. When I use this, it means it is open at this point, and this side, it means it's what? That place is included. In other words, it is closed. So when I say something is closed, that means it is included. The thread is inclusive, so it is what? It is closed. When I say it is closed, this is the notation for closed. There's it. As simple as that. So this is the domain for this, okay? And let's write down the domain for this. The domain for this, so from 3 up to 8. Remember, they are not what? They are not included. In other words, they are open. This is open at 3. This is open at 8. So therefore, I have what? Open at what? 3. Then what? Then 8. Remember from the introduction, I told you that the domain of the function is simply the union of what? Of the sub-functions, right? So this is the union. So this is the domain, okay? So the domain, therefore, is this is what I'm going to do. You start from here, 1, then you end at this side. As simple as that. So this is the lowest value for the x coordinate, which is 1. So before you get to the 1, what's happening? It is what? It is open at 1. So I'll also open it at what? At 1. Then when you come here, what happens? It is what? It is open at what? At 8. Then you also what? Open it at what? At 8. Therefore, this is the domain of the function. What about the range? So for the range, okay, viewer, let's come here. Look. This is x, this is y. This is x, this is y. The x coordinate is the y coordinate, okay? We'll start from the lowest, okay, the lowest value for the x coordinate, right? Sorry, of the y coordinate, okay? And end at the highest coordinate of the y. So here, viewers, let's look at something. When I told that you can use the graph, okay, to account for the domain. If you look at the x coordinate, let's look out for the lowest coordinate, okay, of x. It's not 1, it is 1, right? So therefore we have our 1 here. And what is the highest coordinate for the x is what? It's 8. So what do we have? We have 8 here. So if you can either use what? The graph, or you can use what? The conditions given in question. The same applies to the range. So the range, what is the lowest value here? I have 5, 7, and 10. So what will I do? I'll pick 5. I'll pick what? I'll pick 5 over here. So therefore, so for the range, I have something like 5 here, 5. But look at something. You see here, from here up to here, look. This side is what? This side is closed, right? This side is shaded, alright? Good. This side is shaded, it's closed. So therefore, I'm also going to close this point this way. Exactly, right? Good. Then, what about the highest? Look, the highest coordinate of y. 7, what do I have? I have 10, right? So I have 10 over here. I have 10 over here. But what's happening here? You see, it is open at that point. Is that also? It is open at that point. So something like this is open. As simple as that. So from here, okay, you can see that we have this is what is closed, right? And this side it is open at that point. Because if you trace, look, if you trace from here up to here, see 5, right? So this side it is closed. Alright? So in other words, you have to close it, okay? So 5 over here means it is what? It is included. It is what? It is inclusive. But when you come here, look at the 10. The 10 here, it tells you that it is what? It is what? It is opened. When it is opened, this is what? This is the notation. Hence, the domain and the range of the function is given by this. Viewers, this is the end of the tutorials, okay? I will shoot another video to throw more light on the domain and range of the function. Bye.